For skill practice 1, we are going to plot the points whose polar coordinates are given. There is a polar coordinate system here. Each of these circles is going to be a measure of 1, so that's going to be a distance of 1, and then you can see the angle measures that we have here. And remember that polar coordinates are given with r and theta. If theta is negative, you are going clockwise. If theta is positive, you are going counterclockwise. And if r is negative, you're doing theta plus 1 pi. It's a 180 degrees in direction, 1 pi away. For point A, we have r is 3. That's a distance of 3. So we're looking for circles, a distance of 3. So 1, 2, 3, if you can see my dot here. And then we're at the angle 5 pi over 4. So we find 5 pi over 4. It's in the third quadrant. This is point A. Again, a distance of 3, so I'm 3 circles out at the angle 5 pi over 4. Part B has an r distance of 4, so I'm going to go 4 circles out. 1, 2, 3, 4. Here's that. And then I'm going negative 7 pi over 6. So instead of going 7 pi over 6 counterclockwise, I'm going to go clockwise. So that's going to be 5 pi over 6, the equivalent, right here. So if you think about it this way, if you have negative 7 pi over 6 plus 2 pi, that's going to give you 5 pi over 6. That's the same angle in positive. That's a coterminal angle. So that is point B, an R value of 4 and an angle of negative 7 pi over 6. Part C has an R value of 2.5 with an angle of 4 pi. Remember, 1 full revolution is 2 pi, so 4 pi is going to be 2 complete revolutions, and it's going to be back on the polar axis at 2.5, so right in the middle between 2 and 3, and it stays right there on what would be the positive x-axis or the polar axis because it is at 4 pi, so 2 full revolutions. Part D has negative 3 and 4 pi over 3 as the angle. So remember, I'm still at a distance of 3, but now instead of doing 4 pi over 3, I'm actually going to be doing 4 pi over 3 plus another pi. That's going to be 7 pi over 3, which is more than 2 full pi. 7 pi over 3 has a coterminal angle of pi over 3, which means that our point D is at 3 pi over 3. We're given that r equals 7 and theta equals 3 pi over 2, and we want to find 2 other polar coordinate representations with r being positive and with r being negative. So with r being positive, then we're adding 2 pi or we're taking away 2 pi to get the same identical points. You can add multiples of 2 pi, whichever version you want. I'm just going to add 2 pi and take away 2 pi. So r positive, we have 7, and then I'm going to do 3 pi over 2 plus 2 pi, and I'm going to do 3 pi over 2 minus 2 pi. That's going to give me 7 pi over 2 and negative pi over 2. This means that the polar coordinates 7 pi over 2, and 7, negative pi over 2 are the same points on the polar coordinate system as 7, 3 pi over 2. When we're dealing with r less than 1, remember that is 1 pi away from where the angle of theta originally is. So we can take our angle of 3 pi over 2 and add pi to that and make the r negative. So if we take 3 pi over 2 and add pi, we get 5 pi over 2. And then that means that our 7 would be negative. And so negative 7 and 5 pi over 2 is the same location as 7, 3 pi over 2. And then instead of adding pi, I can also take pi away, which is going to give me pi over 2. That means that negative 7 and pi over 2 is at the same location as well. Skill practice 3, we are converting the ordered pairs in polar coordinates to rectangular coordinates. This means that we are taking r and theta and we're turning them into x and y. Remember that x equals r cosine theta and y equals r sine theta. Then x is equal to 5 times the cosine of pi, and we're talking about radians here. The cosine of pi is negative 1 because it's the x value, and so x equals negative 5. Y is 5 times the sine of pi, and the sine at pi is 0, and so y is equal to 5 times 0, or 0. We then have the ordered pair, negative 5, 0. For part B, r is equal to negative 10, and theta is equal to negative 2 pi over 3. X is going to be equal to r times the cosine of theta, which is negative 2 pi over 3. The cosine of negative 2 pi over 3, using the unit circle, we're going clockwise. Negative 2 pi over 3, it's the same thing as 4 pi over 3. That's going to be negative 1/2. And then half of 10 is 5. This means that x equals 5. Y is equal to r times the sine of theta. Again, this is the same thing as the sine of 4 pi over 3, which is negative root 3 over 2. The negatives become a positive. 2 divides into 10 5 times, which means we have y equals 5 root 3. And this is the rectangular ordered pair of 5, 5 root 3. Question 4, we are working with rectangular coordinates and we're going to polar coordinates, and they're asking for two representations, one that's r is positive and one where r is negative. So if we do r is negative, remember that's pi away from theta. First, let's calculate r. We know that r squared is equal to x squared plus y squared. Remember, if we had a coordinate system here, this is the point negative 2 root 3. There's some angle theta that puts them together. And then we've got r. So we're trying to figure out what that theta is exactly and what that r is. R is then equal to the square root of negative 2 squared plus negative 2 root 3 squared. Negative 2 squared is 4. Negative 2 root 3 squared, the 2 is squared and the root 3 is squared. This becomes 4 times 3, which is 12, and r is the square root of 16, or r is 4. We are looking for two representations, one where r is 4 and one where r is negative 4. Then we need to find theta, and we're going to use the fact that tangent of theta is equal to y over x. Then the inverse tangent of negative 2 root 3 over negative 2 is equal to theta. The inverse tangent of root 3 on the unit circle happens in quadrant 1 and in quadrant 3. Remember, tangent is positive in quadrant 1 and in positive 3. We are talking about 4 pi over 3 and pi over 3. Because our original point is located in the third quadrant, where 4 pi over 3 is, when r is 4, we have 4 pi over 3. And then the opposite, negative 4, is true for pi over 3.